Hey guys, this is On the Spot STEM, and today we're going to be looking at 2018 AMC 8 number 21, and the problem reads, how many positive 3-digit integers have a remainder of 2 when divided by 6, a remainder of 5 when divided by 9, and a remainder of 7 when divided by 11. And for brevity for this problem, to make it nice and short and easy to understand, I'm going to be using the following notation when I say x is congruent to A mod B. So basically, what this notation here states is that when I have a number x and I divide it by b, then the remainder will be a. Now to get started, let's call our number x. We see that x is congruent to 2 mod 6. It is congruent to 5 mod 9. And it is congruent to 7 mod 11. Let's focus on this x is congruent to 2 mod 6 case. Some numbers as included be 2, 8, and so on. And what I notice is that if I have the number 2 and I add 6 as many times as I want, that resulting number will have a remainder of 2 when divided by 6. On the other hand, I can also subtract it by 6. And the way that works is that's how we see negative residues. So if I have the number 2, and then negative 4 will have the same remainder when divided by 6. So 2 mod 6 is also congruent to negative 4 mod 6. And the same pattern applies for all of these here. Like if x is equal to 5 and is congruent to 5 mod 9, it's also congruent to negative 4 mod 9. Negative 4 mod 9. And this also goes to negative 4 mod 11. Now this is where the crux of the problem states. Basically, I see all these negative 4s are the same in each of these three congruencies here. Now what this basically means is that when x is divided by 6, it has a remainder of negative 4. When divided by 9, it has a remainder of negative 4. So what that allows me to deduce is that x will have a remainder of negative 4 when divided by the LCM of both 6 and 9, since it will fulfill these properties. So the LCM of 6 and 9, as we know, is 18. So I can say x is congruent to negative 4 mod 18. But I also have this 11 case here that I want to apply. So x is also congruent to negative 4 mod 11. So it's also going to be congruent to negative 4 mod the LCM, which is least common multiple of 11 and 18, which happens to be 198. So I see x, let me zoom out a bit. X is congruent to negative 4 mod 198. And so basically the way we would work from there is actually pretty simple. The problem is pretty much almost done. So a number that's congruent to negative 4 mod 198 is obviously 194, because it's simply just negative 4 plus 198. The other numbers we'd have that are also congruent would just be 392, 590, 788, and also 986. Now you may be wondering how we get these numbers. I'll give you a minute here, or just pause and then think about this. And once you're ready, just click play. Okay, so the way we get these numbers is, as I said in the beginning of this video, if the modulus will remain the same no matter how many times I add the number here. So I can add the number 198 as many times as I want to x, and its remainder will always be negative 4. And I can verify with all these examples here. For example, if I have the number 986, and then I add 4, and then divide by 198, the remainder will be 0, which means that it works. And here we see that we have 1, 2, 3, 4, 5 correct answers, so the answer is indeed E. And that's how you solve this problem.